And we should be live, I think. Just make sure. Yes. Let's check on my phone, see how the sample is. Oh, nice. Move some of this mess. On the phone, you can connect. Hello, hello. Man, I'm trying to hear what I say, but it's so delayed. That's fine. Maybe a little loud on the voice, but or on the background. I'll turn that down a bit. Hopefully that sounds good. I guess I can't just chat. So. Say it's fine. Let's get the show on the road. All right. What do I want to show? I don't know. I guess I'll just start off. Apologies for the lack of uploads. I've had a bit of a sore throat and a cough for the past week, so I just didn't feel like I was ready to record. Last week I didn't want to be coughing a million times in the recording and didn't want to strain my voice. As you can maybe tell, my voice is kind of strained as is, and I hope I don't just cough a million times during this live stream, but we'll see what happens. It's gonna be a bit of a short live stream. I'm gonna switch off of doing that robotic arm because I have gotten up to the point where I guess let's load it back up. Alright, it seems to be just about ready to be printed. I'm going to do another, just look over it, just to make sure everything's going to line up, make sure all the bolt holes are good. No. Close you. Try this again. Open you up. And everything failed. Perfect. Yeah, so as it stands, I basically have the whole arm ready. I'm going to go along it. I made these little clips so I can strap like cables to it to get a bit of a cable management going. So I still have to do those little add-ons to it, but that's not really worth last year, and that's pretty boring. And then I need to figure out a better way of doing these gears, because I have specially designed gears where I basically took this base gear that's here, added a big extension arm to it so it actually connects to here and actually extends up. So I have the proper parts to connect to the section to make it work, but whenever I refresh this assembly, it seems to forget those parts exist, and it just completely breaks everything so it doesn't work. But it does work, and then if I have those updated, these jaws will work correctly and will work in the future. So all I really need to do for this now is on the right screen. Yep, I figured out you can do this in SimScale. It's pretty easy to do, and I was just going to do some finite element testing on it, make sure we're getting adequate numbers for everything. It's going to be a little wishy-washy because right now I print in PLA, but 3D printing and a solid block of PLA are incredibly different. So I've heard you kind of want to do this in ABS instead, because as you can see here, ABS about the same density, a little bit lighter, about the same Poisson's ratio, but the Young's modulus is much smaller, so it's not as strong of a material, which is probably a little closer to what this would be if it was 3D printed, because it would be hollow on the inside with only the outer shell actually being solid. So I think that might be the way to go. The song does not do well with just casual talking over stuff, but oh well. I just have the Undertale soundtrack going on in the background just for a little more interest than just my boring old voice speaking. So yeah, figured out this. I'm gonna have to mess around with the material of it to try to get a good grasp of the actual strength of these blocks. And I'll have to do a bit of finite element so I can actually figure out what forces I can expect across each of these. And so I'll be just doing that I'm just going to do in when it totally stretched out straight. I can't really do that because SolidWorks is not happy with moving it. But yeah, so we'll be looking to just be doing that stretched out straight. So that's going to be the max actual like strain felt on these bits. There's not gonna be any crazy movement and stopping and starting, so not to worry about like dynamic loads. It's all gonna be static loads for the most part on these pieces, and those are gonna be at the greatest when it is fully extended and you have all the weight somewhere over here leveraging it like a big old beam. So I'll have to do that, figure out those weights, figure out the forces in each connection. And then I want to do a little bit more for this base, because this base, idea behind it, I'm going to have a big metal plate in the bottom, and then I think I'm going to want to make like a plastic tray on top of that plate, so I can screw in the Arduino. I'm just going to do a breadboard. I don't quite feel the need to go and do a crazy PCB to get all the wiring nice. I'm just going to have all the wires go down through that hole, connect into the breadboard down here. Might have to like tape them in place somewhere so that the breadboard that'll just get pulled out when it rotates. But that's some simple things I'll just do off camera because they're not exactly super exciting to watch. And same with the SimScale. I think, how long did this one take? It took 4 minutes to do the test, and basically you just run the simulation, and then it's just loading bar simulator. You just watch it slowly go up and up and up, and then it's done, and then you can actually post-process it and look at the pretty things. But seeing as we're not doing that robot, I'm gonna close those for now. Rebuild and save. Yeah, you're not happy. Yeah, I don't care. I'll fix that later. So instead, we're gonna work on, as I said, a bit of a niche car product. And so I live in Canada. As you know, Canada gets cold, and I do happen to like skiing, as I think I've said before. I showed the video in the one live stream, so I think it should be somewhat obvious that I do like to go skiing. And while you're up at the ski hill, it's nice to, you want to lift your wiper blades off of your window, because if it's like a super snowy day, you can get a bunch of snow on your windshield and actually have the wiper blade freeze onto it. Especially if it was like snowing on the way up there, you have your nice heated windshield to keep it from freezing and just to keep your car warm. You get up to the hill, your car slowly cools down from all that heating going on it. The windshield then freezes and you have your wiper blade freeze to the windshield. You then have a frozen wiper blade. It doesn't wipe the snow off very well and it's stuck to your windshield, so it's a pain to lift off. Oh, sorry. And so you want to lift your wiper off your windshield, which is, excuse me. It's fine and all, especially if you have just like a small car, because it's easy enough. You can reach over your hood and grab the windshield without too much of an issue. Did that work? Yeah, cool. You can reach over, grab it, lift it up. The one in the middle can be a bit of a pain because it is way off into the middle of your windshield, so it can be a bit farther of a stretch, but it's usually not terribly bad. But if you get anything taller than like a car, like once you start working into trucks, it can get to be kind of obnoxious to lift those wipers off. Especially because, I mean, let's just do a quick search. North Face. Just casual jacket. This, I mean, North Face, not to diss them, they're just kind of a nice casual jacket. Not super high end, not super low end. Let's see if I can find just a regular. Just my winter jacket. Jackets and vests. So, I mean, this is just a padded jacket and running for $400 Canadian. You talk about going into proper ski jackets. I mean, you're looking at $450, $500. It's just a down hoodie, but you start to get into multiple hundreds of dollars. I've seen jackets go for $700 for some of the more premium brands fairly easily. And not to flex or anything, but I went and bought like a onesie suit because I figured it was worth the money because it's as like an investment. And I recommend it if you are a big skier. I highly recommend getting a onesie. They're incredibly comfortable, incredibly warm, and it's kind of fun not feeling like you're wearing pants on the ski hill. And you don't have to worry about getting snow in anywhere. You're just fully sealed in, so it's all good. But the onesie I bought was like $1,200 Canadian, and I really don't want to be reaching over my windshield to pick up my wiper blades, brush the front of my suit up against the car, and just get covered in dirt. And so a couple of years back, I figured why not make a little lifter so I can just press a button, flick a switch on the inside of the car, and it'll just lift the wiper blades up for me or lower them for me. And so that's kind of where I came up with this idea. I got a couple pieces built together, and I guess the assembly didn't save the last time I made it, so I'm just going to quickly rebuild it. And we're going to be doing some modifications to those parts because I made all these parts without taking the wiper blade off. I just did some measurements and I made this. But since then, I've taken the wiper blade off. You can actually get a proper measurements on this bottom section here, which is where I'm going to be attaching it to. And originally, I was thinking of like patenting this idea because I thought it was a pretty decent idea and could actually sell to like people. I imagine people in trucks might want it, but done some thinking after that and looked into heated wiper blades, which is kind of the one competitor to it. And I just think heated wiper blades are kind of a better all-around solution. I mean, they may be slower, because I don't know how long it would take once you've hopped into your car at the end of the day for the heated wiper blades to melt the ice off your wipers. If that's like a 10-minute process, then it might actually be worth it to just have a wiper lifter. So you can just lift it up, and then it takes like 20 seconds to put it back down. So that might be the one advantage it has, but it's not going to help with any sort of freezing. Like once you're driving, if your windshield gets too cold, heated wiper blades will help keep it warm and keep your wiper from freezing. Just lifting it off isn't going to do that because you're not going to want to lift it off while you're driving. And I just don't think I can match the cost effectiveness of heated wiper blades. I mean, these, you can use any aftermarket wiper blades with them, in theory. I mean, the wiper blade is no problem. It's the actual wiper, like, mount that's the problem. I kind of lucked out with my car, where it's a pretty easy mounting surface. It's relatively flat, nice big section to stick into. Let's see. Where is? So I'm using. I got these like linear actuators. I'm gonna be sticking those on the wiper somewhere like that. I'm gonna put them on the side, and so with this length, you actually have room to do that. But I've noticed in a lot of other cars, and like especially my dad's truck, it maybe has like half that distance, and so it just isn't feasible to have a linear actuator there. And I'm not quite sure how else to do it. I was thinking you could maybe do something with the actual rotating section here, if you could somehow build it underneath that and just have a cable come through there, but I don't really see that happening, so I don't think it'll really work with a lot of other cars, but I'll make one set for my car at least, because I mean, speaking of prices, I think it costs like $40 maybe to get like heated wiper blade, and I think just one actuator was about $40, and so you're already running at least twice of what heated wiper blades would cost you. So I just don't see it working out commercially, but it'll work out personally for a bit of a fun project. But enough of that, let's get around to actually building this thing. So first, we are going to create an assembly. And we are going to base it off of this. This is where everything mounts into. And let's switch this off. I don't want to use looking at all my files. And I've got 4 more pieces that I want to attach. Okay. First, we'll just go with the actuator, I guess. Let's do a fancy one. Should be fence made with mate. Make sure it's nicely centered. Just like that, perfect. And does that line up properly? It's not going to, is it? I don't want to have to draw on this, but I might have to. Because in the actual actuator, it comes with these little, can open it, yeah, little metal clips to attach it to stuff. And so I'm going to use one of these. It's going to go on, might as well take it all out. It will attach to the back of it. Something like that. I guess to go with the picture, I don't know. It's a camera face. Go like this, it's going the opposite direction I want. So yeah, it's mirrored. Yeah, I want something like that. And then this little clip is gonna connect into, that bolt there is gonna connect into that circle to lock it in place. Which, I guess I might as well make that little metal bracket and use that to line everything up. So I'll leave that as is for now. Do I want to do that in this? I guess I should, yeah. Let's just assemble the rest of the pieces. So we got the arm of the actuator. We're going to stick that in U. Make U are going to be parallel. And then take the front face of U, back face of U, and you are going to be advanced mate, distance mate, max of 50. Guess that's not completely true, is it? 2 and 0. That's the opposite of what I want. There we go. Actually, I think I am gonna just for now stick those together. Still gonna slide in it, yeah. Oh well. So we got this piston here. Okay. Piston there is gonna extend and contract. That's fine. That looks to be about the same as fully contracted, and then when it's fully extended, it'll be out like that. Okay. Next step, we'll take this bad boy, and it's going to connect right like that. So the idea behind this is I still have to make another piece. It's going to connect to the front of this piston, and it's going to go underneath this arm to this backside of it. As the piston extends, it'll slide along that arm until eventually it slides past that arm, and that'll allow this to slam back down, which is one of the things one of the kind of needs of this is one of the things you do with your wipers is if they do freeze, you just lift them up and smack them up against your windshield, and that'll help break the ice off of them. So I wanted to make sure that was a feature of this as well. And so instead of, I could have just done like a motor with a cable attached to it. Instead, I have this so I can have that mechanism of it sliding, slam, sliding, slam, and then it can just slide back and forth piston wise, which I'm going to change some dimensions because there's touch in there. This whole thing is going to need big change dimensions, which is not going to be fun, but that's kind of the idea behind it. And then the whole way this actually acts on the arm is I'm going to have a cable running from it. And so cable is going to connect there. I guess I had that hole there because I'm going to put a bolt through there to hold it together. But yeah. Cable, we're just going to loop it around here and then connect it together here, and then the cable is going to run down to there, out through here. Well, run down through there along this channel, and then it's going to go through this eyelet here, and that will keep it in line because it's going to attach to the wiper. The actual wiper is going to sit kind of here. If you can see, I guess I'll take this out. So this is going to connect on this wiper sit. Wiper sits like this on the car. So the main body of it, the actuator, is going to sit on the side of it. Then this curved section is going to sit on the top face here. We'll have the cable pivot will sit on the side here. Originally, I had wanted to do everything on the top of it, but with the way it sits under my hood, there is very little clearance between the top of the wiper arm and the actual hood. So I switched it so it's more streamlined, more flat profile, so it can actually fit underneath the hood. And then we'll have circle bit, that rotating bit is going to sit like right around here. The cable is going to run from it through that eyelet and then connect to somewhere up here on the wiper arm. I think I did a bit of math on it, and I'm going to need, I think it was a 5 centimeter extension from the top here. And so I need this to go, a piece to go, this is so hard to show. I want a spring tension piece on the top here that lays flat, and then you tighten it You spin the bottom section, and that'll tighten the cable till it locks at 90, and then from there it'll lift the wiper blade up. I just the actuators I got aren't quite strong enough to do that themselves. I could have gone for a stronger actuator, but you start running into the stronger it is, at least for this model and for this size, the stronger it is, the slower it is. And so these ones, they go 15 millimeters per second, and so it'll take about, let's say, like, should take about 2.5-3 seconds for a cycle of it, and that's at 60 newtons. I could have gone higher than that because it's just all torquing on the inside of here. So if you go half as fast, you'd have twice the torque basically. It's just gear ratios. But then you're starting to get into it takes forever to lift the wiper blade, and I just thought that was too slow to go anything slower than 3 seconds to lift the wiper blade up. I don't want to be sitting for 10 seconds while it goes. But it might be something I do in the future, and if this works well enough, I might iterate on it, introduce like an actual controller to it, and then I can go with a slower wiper or slower actuator with more torque on it, but I don't have to think about it at all. I just press a button on the inside of the dash and it will do the lifting and all that for me. Because as it stands, I'm going to be basically, I'm just going to have a two-way switch. Switch it one way, polarity is positive and the actuator extends. Switch it the other way, polarity is negative and the actuator contracts. And then there's neutral in the middle of it. But doing that, I'm going to have to be focused on it. And so yeah, I don't want to be taking forever to lift up. I don't want to just be staring at the wiper. And then stop. I just want to do quick. Switch it. Nope. Stop. Nope. Back down. So yeah, that's going to connect to the bottom here. And then as far as the actual connection to the wiper blade goes, I wanted to make it as mechanically attached as I could. I didn't want to use any glue on it because I wanted to make something that I could stick on anyone's wipers, and I didn't have to like glue something on there and then you're forever stuck with this glue splotch on your wiper blades. But at least for mine, at least for this proof of concept, I don't think anyone else is gonna use it. I'm gonna stick, I have a bit, it was like a Velcro glue, or Velcro tape, not glue. And so I'll stick one side of the Velcro on the side of here, the other side on the actual arm, and I'll just stick those together. And then I have this secondary piece right here, which was, that'll attach right there-ish. Attached there. I'm going to print that out of the flexible filament stuff. And I didn't quite get the dimensions right when I did this the first time. And I didn't want to worry too much about them because I was going to have to redo them all anyway. But idea behind it, this is going to all be kind of flexible stuff. And I'm just going to take a hose clamp, wrap it all the way around, and then we'll just tighten the hose clamp up. And that will provide a bit of, I'll be mechanically attached to it. That'll keep it nice and snug together, and they'll take the brunt of the load, hopefully. And then that Velcro tape could just be there to help prevent it from tipping side to side. Might need more, because it is going to be 60 newtons of force applied there. It's going to be more than 60 actually right there. So we'll see if I need to beef up this actual connection. Hopefully not. I think the tape is good for 5 pounds per inch. And I think none of the force is going to be, all the force is going to be like parallel with the tape. So it'd be easiest to pull the tape just straight out sideways, but going sideways, it's going to be very difficult to pull that tape apart, so I think it should be fine. Worst case scenario, I just rebuild everything. Nothing too complicated there. So yeah, that is that. And I guess we will start rebuilding it. First step, I guess we'll make this little mechanical clasp so we can actually get stuff lined up properly. New part. Boom, top plane. I'll trim one offset. Offset. I guess we should get the rest of the dimensions first. Inner dimensions of this bad boy. It is not perfectly square. Why would it be? Going on the bottom of it. Let's go outside of it. It's a nicer measurement. Oh, 10.6 millimeters. Whole thing we're looking at roughly 15 mil tall. 15 mil tall offset. Reverse. This thing is 0.9. Is it consistently 0.9? Not really. We'll say 0.9. 0.9. Cool. Take you. Extend you up. Take you. Extend you up. Take you. Delete you. You are still 8 mil? Yeah. 7.9192. We'll round that up to 8 mil. Boop. And do I care about the fillets? I guess I should. 3 mil? Oh, 3 mil is way too big. 1 mil. So just for looks, but we'll put them there. Anyway. Some fillets on it. Alright. Bottom of the circle, we are looking at 9 millimeter. And you are 4.18, 4.13, 16, 1. Say it is 4.15. Numbers are kind of off. I wonder if that is that a metric measurement or a imperial? Right. 2128 and then 530 seconds. Might be 530 seconds, but by the way, we'll just do millimeters. Good enough. We want you centered. Center dot. Center line. Horizontal. Hopefully that plane isn't extremely loud. It might be extremely loud, and I apologize. I have the memory of a goldfish. Let's remeasure. So you're looking at. I hate trying to get accurate measurements. Say 9 mil. Somewhere around 9 mil. So 9 mil to the bottom plus 4.15 divided by 2. That'll give us that. And that's not going to be perfectly centered. Is that fine? I guess that'll be fine. Is it better to have that circle centered? Or is it better to have it tangent to the top? I think tangent to the top is what we want. It'll look so much nicer. Tangent to you. Tangent to everything. Can't do tangent to everything. Well, so there's a circle. It just has those two mates, so I can not. Because it's got the same center point. I guess I'll delete it, yeah. You, redo you. You are horizontal. You are just going to be tangent to everything. Because your position doesn't really matter. Maybe? No. Tangent. Thank you. You. You trim that side. So now it'll cut across, it'll cut our two holes. Go up to surface, boom. Bam. Sketch. Last hole in the middle of here. Take you, you are horizontal, size-wise. Should be the same as the top ones. 4.17, 4.15, 4.7, yeah. 4.15. Do them all even. Straight cut. Up to you. Bam. Got a bracket. Cool. Save the PC. Metal bracket. Sorry, I switched to full screen camera because I don't want you looking at all my files. That's all. Assembly. Circle components are good. Metal bracket. Undertale soundtrack is such a banger. It's so good. I mean, just great songs. Parallel. Alright. Metal brackets in place. Maybe almost kind of lines up. Good sign. Take you. View your mates. Parallel's good. Concentric's good. Coincident. No. You are concentric. Can't do. How close are those? Those are. Alright, pretty good measurements. Those must be pretty darn close. Can I? What is that gap? I must know. .02 millimeters. I'd say that is close enough. Right where we want it. Sorry for the loud truck. So yeah, bracket goes there. We'll go through the bottom. Should be fine. I'll have to double check to make sure that none of this will run into anything, but I'll worry about that next time, I guess. So what I want to do next. I don't know. How long I've been recording for? 41 minutes. That's not bad. No chat. That's par for the course. That's just how she be. Got no subscribers. I don't want to connect that. I don't even know how I want to connect this bit. Guess I might as well just make it, and that'll make the rest of it adjust to it. Why don't I? Okay. Repair. Give her a go. Her. Excuse me. Do I want to use the metal bracket for? How's the metal bracket fit? So, bracket. I don't want that. That's gonna be taller than I would like. So we're gonna make it all custom. Right, because it's gonna fit. Actually, fits like that. Yeah. It's gonna be too tall. All right. So, easiest way to do this part. Guess I might as well do the slot of it first. Yeah. We're gonna take a circle. Might need 2 circles. Let's see, 16 mil 16.03. Other side is 16.1. I'd say that is a fairly consistent circle of a diameter of 16 and a bit. We'll need a bit of space. We don't really want it to be a friction fit. We want it to slide nicely along that top section. So we'll do that. And then we have the square bit in the middle. And that bit is 12.07, 12.02, 12.02. We will say that is 12.25. Gives the slide as big a wiggle room Then disconnect you, disconnect you, disconnect you, disconnect you. That will give us the shape, inner shape of the bit sliding on this piston arm. I have a feeling that's just gonna get clogged with snow. It'll make the whole thing useless. But until it gets clogged, it'll be fun to look at. So what do I want to do next? So in actuality, we don't need the bottom bit. We're just gonna have it sitting on top. Do you want it sitting on top? Top, yeah, we'll sit on top. It's gonna be pressed there. That's gonna be forcing down on it. Yeah, we don't need to go a full link. Would a full link work better? Full link. I see snow freezing if it's a full link. Might make more sense because you might just get snow build up on here in the slides and just lifts up. So the full link would hold it in position. But then I also just see a bunch of snow getting stuck in the bottom of it and just getting completely frozen solid. So we will leave it as is, and we will just make the bottom section flat. And because I don't need that bottom section, delete you. Take you, we will offset you. What in the actual is that shape? 2 mil. What? What the? Solid works. You're drunk, go home. Offset. There, that's a little better. 2 mil offset. So what we want, is that thick enough? 2 mil at the side, big shape. I think we'll go 3 mil. I don't want to go very wide with it, but also don't want it to just immediately snap in half. And it is going to be winter, so it is going to be nice and cold and brittle, so I'll go a little bit bigger. Why do you do the SolidWorks? Alright. You solid like you. Let's put some dimensions to hold stuff in place. Should be the same. Alright. Nice. Alright. Everything's locked in place, not gonna move. How far do we want to extend this? It's gonna need to go the full length of the actuator, basically. So sitting on the actuator, we'll have this shape up to right around here-ish. So when it's at its minimum, we can have it up against, but when it sticks up, there'll be extra space, and you do want it long enough so that if it goes to maximum, it doesn't slide off. So if we go maximum length of this, we can make it 55 millimeters. And that'll give us a couple mil of actual, like, extra room. Max, we could do 56 and a quarter. So maybe we'll do like 54 millimeters. And that'll give us a bit of wiggle room on either side for weirdness. 54 mil. nice little horseshoe shape, I guess. I'll just sit on top. Then I don't want to do the leg that sits on top. Just a circle. I guess that works best. I'll go circle. Is there a convenient plane? There is not. So, features, reference plane. Take you, tangent to you. And go to parallel to you. Bam. Yeah, so plane at the top. And I'll do a little circle. How big do you want to make the circle? I want to say 10 mils too big. 7.5. It's a nice number. 7.5. And might as well make it as far back as possible. Okay. You. Vertical. Straight to boss base. One direction. I hate how if you're on blind, you like switch to something and then you try to like cycle. It's because I want defaults to blind. I want to go to off to surf, just like a surface. But if I'm at like this position, I need the surface to be that top layer, and so I want to use the arrow keys, but the arrow keys don't work. They just mess with this. In the direction 2, we'll go blind. We'll go. It's 4 mil. I'll be 7 mils off the top surface. Is it gonna be fine? I think it'll be fine. I'll build it C, I think. Looks reasonable to be about yay big. That's egregiously large. Should be fine. I guess that's yay big on my screen. I don't know how big that looked on your screen. Probably completely off. Quick chat check. Nobody. Alright. To connect to the front bit, just slide it on. And I guess the easiest just to bolt through. Yeah. Do not reuse the bolt they gave me. Is that too wide? It is kind of wide. Yeah. We're gonna get our own bolts and have our own bigger-ish bolts, small enough. Like that flush, that will vary. Stick that through. So not on the back of it. We could make that completely flush, yeah. That's the bolt we'll go through. That is the bolt we'll go with then. New shush login truck on the road. Is this the right nut? That is the right nut. That looks like a very big nut, but it's the right nut, so that is what we will go with. It was a long truck. You don't even have any logs on you. Why are you so loud? Okay. What kind of shape do I want to make this front piece? Guess might as well just extend it further. But make it solid. Except for the end. I'll put a cap. want it to be as skinny as possible so it's as strong as possible. Yeah, let's sketch on this face. That's not where I want it to go. Take you, we'll sketch on you. First we'll convert you. I'll trim out the inside, we don't need these bits. Do I just offset? That might be the play. Kind of just looks like it's offset anyway. Let's see. This inner vit is going to be 6 mil across. So we will do. See if we can just offset it. So this is 12.17. The inside is 6 across. So it's going to be a 3 mil offset from that inner face. Can I just offset? I can. Nice. 3 mil offset. That should sit properly on top of there. Maybe we'll. If it's a little tight, that's fine. Dang it. Q will extend these legs out. To make that a full piece. It doesn't. Looks like SolidWorks thinks it is, but it should be. Then we will extend this. Blind. How far do we need to go? We're basically flush against the front. I guess, yeah, this all depends. A whole bit depends on this. See how get that measurement? Not really. Figure out the minimum distance to the circle on it. Looking at 2.75 mil to the front corner of the circle. There's no corners on a circle, but you know what I mean. I guess that part doesn't matter. Yeah. So how far do you want to extend it total? We'll need that to extend past there. So we'll go like 10.5. Yep. Boom. Do I need to put a cap on that? Not really. Should be fine. Sketch. So we're doing circle bit. Oh, I need to figure out where this was centered on there. So center the okay. Very good. Distance to the circle. We are going to want. What was it? 2.75? Again, memory of a goldfish. 2.9, yeah, 2.75-ish. We'll go a little bit shorter, because if we go too long, it's going to run into this top bit, which we don't want. By this front bit. So we'll do a little bit shorter, so if anything, it is too close. So yeah. So 2.5 then to the front edge of that circle. And this thing is 3.92 across for that circle. There's no reason we don't just match it to the bolt though. bolt is 3.3 across. So yeah, we'll go 3.8 for you. 3.8. And this is going to be 3.8 divided by 2 plus 5. Man, I really do have a attention span of a goldfish. What's this dimension? It's 2.26. Okay. 2.5. 2.5 for you. So that should be distance-wise good, and we will line it up with there so it is in the center of all these circles, because that's where it's lined up on the actual bar. And I'll just take it through here. Could maybe do some whole wizardry magic, but I think it's just, I find it easier just to do the stuff manually. I'll sketch here. And for this, that's not the bolt. Too many bolts. I should make a designated bolt holder or something. Just sit here. So this is going to be 6.6 across. We'll make the circle 7. Boom. And to make this flush, we'll be looking at roughly 3 mil deep cut. Blind. 3 mil. Check, nothing. So, sit through there. I'll be halfway through there. Still decent bit of meat to support it. And then yeah, we'll just cut the nut into the side. Take a polygon. How are we gonna print this piece? I guess you print it up like this, and that should all support itself well enough. Yeah. So if that's the case, we want this orientation. So as you print out from the bottom, it's supported, it's supported, it's supported. If we rotated this the other way and say printed with this as the bottom, that would be supported, that would be supported, and this is just a big flat spot that would have no support on it, and so it would flop down and just not look so good, which might be a bit of an issue for the top bit of these arches, but they should be fine. They should have enough support on either side to keep them from collapsing. Because you can't just print into midair, at least not yet. In the future, we might be able to. And if I just had, what is it called? A resin printer? I think that's a slang for it. I don't know what the actual term for them. But if I had a resin printer, I could do it. But I do not. So as such, we will print it with FDM printing in mind. So this nut is a little under 8 mil across. It's a little over there. So we'll go 8.25. 25 mil. Give it a bit of breathing room just to make sure it doesn't catch up on itself. We can actually get the nut in there, but not too much that the nut will just spin freely. And then I guess I might as well cut this 3 mil as well. And with that, we'll stick the bolt in one side, stick the nut in the other side. They will connect, attaching it to the actual actuator. These will be countersunk so they don't extend past the sides of it. This is the knob on the top that will press up against it. Should I be worried how the forces look? So it's just gonna be pulling it sideways. You can see it wanting to lift off, which might be a problem, but I think we might leave it with this as is. Worst case scenario, we'll make some slight modifications, but it should be fine as is. I guess I'll have to save that piece before I can use it. That work? Nice. We want slider. Slider top? Sure. See here, I'm not sure why I'm bothering. I should just like clean up my. I don't think I have anything weird. I just don't like just don't like the ideas of people just looking through my files on the internet. But I don't know if I'm constantly going in and out of files. I'm going to actually show them occasionally. But oh well. Attach you like that. Make our life easier. We will make you parallel. Okay. That'll sit like that. That's nicely up the front. Also support it, lines together. That goes up to there. It's not going to run into there. It doesn't run into there. And then I'll slide out to here. Doesn't slide off the edge. And I'll slide back. And now I just need to raise that so it actually works with that. Which means I have to move this. Can I connect them together? Doesn't need to be a big flat plate. I kind of want it to be a big flat plate. It'll keep snow and stuff from going any further. I'll just kind of sit on top of it. But gotta cut a channel into the bottom of there. Side forward on connection. Now slide back. That might be doable. Right now I'm just thinking if it would be possible to get rid of this like designated actuator arm and just have whatever interacts with this knob like integrated into the underside of the circle. If I could just cut a channel in there, I'll leave this whole extended arm out, which I might do, but might be safer just not to. Oh, I'm gonna have to extend that out as well. Oh. So many things to do. Time-wise, hour 9, no chat, cool. I'm not sure what I'm gonna do with this. Just need a hyper song. It's just too slow. This one I really liked. Which one was it? Is it this one? I think it was. Oh, yeah. It's not good for just chilling in SolidWorks, but it is a very hype song, so it is fine. So might as well save this. It doesn't save. Oh gosh. Assembly 2. Hyper. Assembly 1. Still gonna need to lift it up because we can't have the knob going through the cable. That's non-negotiable. Now look at this, I just want to lower the height of that knob, but then I need to realize that it's not actually that big. To make a more complicated latching mechanism. Cut a notch out. So it's in the notch. Slides forward until it falls out of the notch. And then it just bumps into the side here. Yeah, no. Okay. And the little peg leg is here to stay. Guess before I adjust that, I might as well adjust this bit so it fits properly. Just gonna change that 22. So hard. Part was that even? Exit sketch. So that is this little square. What is this? Temmie song. Get out of here, Tem Shop. So that's that square there that I cut out at one point in time. What is this bit? You are Boss Extrude 2, which sat on top of that square. So if I make that square bigger, this dimension is gonna stay the same. Me. Let's just see. How much wider do we need to go? Bro. Exit you. You evaluate. That inside face to that inside face. We are looking at 1.3 millimeter. So we're gonna make this whole thing 1.5 on this side, so you go 1.5 on the other side. Should be good. So 1.13 on this side as well. Yeah. Work. 1.13, yeah. 1.5 either side will give us a bit of wiggle room. These pieces, how wide are they? 2 millimeters thick. Probably gonna need to make that beefier, aren't I? Yeah. Okay. I'm gonna adjust this and it's gonna break everything. You just wait. So you're gonna go 3 wider on the middle and those outside pieces. And those 7 wider, so 29. Nice and chunky. And stuff actually worked. It's wrong, but it worked. What is this? We want you to be 4 mil wide. rid of this dimension. You can attach to you. And we'll just make you 4 mil as well. That should be fine. Still hasn't broken. So, Christmas miracle. Okay. How's the measurements? Am I dumb? I think I am dumb because that looks way bigger. Yeah, so we're looking at 1.38 now. Yeah. 1.38, which is definitely wider than I wanted. I need to adjust that as well. Huh. 1.38. 2 millimeters skinnier. 27. Does that fix all of our problems? Bam. Did not. Or did it? Ooh, that looks better. Measure. Why you just work, please. Not clicking the same thing. Measure. We want that face to that face. No, that face. Okay. Normal distance 0.38 mil, so got about half a mil there. Is that too skinny? Do you want that wider? I think we do. I'll go back to the 29. Because it was only... wasn't that extremely wide. Do I then extend these in? Actually, I guess the side can be flush with this. And this side, it just looks nicer if it's all one flat line, but there's nothing wrong with it being tighter. Yeah, we'll pull this side in then. Trying to change that mate. I know. We'll deal with that later. Okay. So we like this distance. We just need to change that distance. Which of that distance do you want to change? 2.9 mil wide right now. Let's see. Bring that in 2 mil. We'll flush it up against that face. And it should be good. You. Bring it in 2 mil, yeah. Back to you. You can be 27. Do I need to change it? I don't think I really do. Boom. You are still centered and you are way too close. Take you out. That looks so wide. It's like probably 2 mil. Okay. 2¼ millimeters. Which, to get into perspective, is a gap of roughly that. I think it's too much. I think I'd like it. I'd like it to be a millimeter wide. I don't want to go too much wider than that. So we'll pull this in a little bit more. Yeah. That was 2.38. 2.28. So I want it to be 2.28 minus 1.18. 5 and a bit. Well, let's go 26 mil. That spacing looks better now. U 1.28, which is fine. We'll just have to remake that hole so it lines up. To make that line up, we need 15.2, so we're gonna 15.2 would be 7.7-ish. That hole, you are cut extrude 1. Base you off of that side. 15.2 divided by 2 plus 0. Man, I really hope the mute button on my mic works. That's gonna be so loud to listen to if it doesn't. I like that. Take you off. And we will now distant mate you. Standard width mate. That face to that face to that face to that face. Middle of there. And this is still too skinny. That might be too skinny. That face. That face. 3/4 of a millimeter. That is pretty tight. So, extrude 1. Let's make this 8 mil to give it a little bit more space. Such an awkward environment to trying to think of like designing around snow buildup and ice, and it's just not an easy environment at all. Okay. Not on what we're gonna need to rechange the height of this, unfortunately. Yeah. Oh well, it is what it is. Is bracket good now? Say it's good enough. Good enough. Anything that's gonna change is gonna be this shape here, which shouldn't affect this bit here. This will have to change, but we'll do that after. Moving this. I think I might want to fillet that corner, like fillet that corner, just for aesthetic purposes, but we're good. All right. What do I want to change this? What was this again? I'm gonna cut sweep that, and then I extruded that bottom bit. Which I guess. Hub prom 6 mil. Do like 10 mil. What's that look like? $10 mil. So that clears nicely. And then we just cut that slot up a bit more. I think we'll need to extend the slot, yeah. We'll change the angle of the slot as well. Okay. Ideally. Oh, I don't want to do this math right now. Looks like we'll need to extend something. Because those don't overlap in the slightest. I think it's so much easier with the initial model. Let me open that model up. This was so much easier to do. I said, actuator, you just locked it in place. You had a pivot stand. I was gonna have to definitely extend the size of this top circle because the cable is going to sit along there, but that's the idea behind the same mechanism. So I would have the pin there, it would rest on the inside. This is going to want to rotate this way because the wiper is going to want to pull it back to neutral, and so it'll rest, extend past, and then slide back up. So I can slam up against the windshield. And then I could also extend this all the way back out. Because once it slammed against the windshield, this would go on the opposite side of the pin. And then to pull it back in place, I would have this spring set it so it naturally rested right here. And then I just push the pin underneath it all the way back out. And then it would reset on this side, which is so much simpler doing it in 1 degree, right? It's like 1 dimension almost. Or this one, I got this dimension and this dimension now. But it looks like Could also extend a piece from the top here. Have it basically resting on this plate. Instead of having this knob in the center, having it sitting over it there, which might be the way to go. I think that will be the way to go, only the way to actually get this to work. Because then I can actually lower this knob, make this, the whole vertical profile smaller. Basically make this so it rests right on top of here. I just extend that so it interacts over here. We'll have a little less torque. So when I did the math, it was 1-to-1 this action arm to the cord action arm. So now we're losing a bit of torque because we're using a smaller lever arm than here, which might be an issue. But we can also extend the bit that goes on the top side of the lever, or top side of the wiper blade, so that is longer to give us more torque up there, so it should be fine. But then we might need to spin this further to get it to work, you know. Oh well. We'll make it one. We'll make one. Worst case scenario, I rebuild everything. Best case scenario, it just works. The second best case scenario, I just realized it's a dumb idea, and after the first prototype doesn't work, I quit with it. But I don't know if that will happen. But I think I might leave it there. Yeah, I think I will. Keep plugging away at this, get it. See if I can get it up and running. Showcase some of it on Thursday. Now that the robotic arm is at the level that it is, I would like to go, so I'll just go on full cam. Yeah. Now the robotic arm is as it is, I would like to go and do the sim scale test, do the sim scale testing, get numbers for everything, make sure everything should be strong enough for it. This is easily going to be the biggest print I have. I'm going to print it all. I want to kind of match my computer case and setup, and so I'm going to do everything in white. Let's actually load it back up. Assembly one, we'll close you. Let's see what rebuild. Go here. Yeah. Just showed off the last bit of this live stream. Yeah, so ideally, the plan is to print everything in white PLA. I think that'll look really nice. You have the contrast between the black and red servos, nice white pieces. And then I'll do some of the grabber in black as well, just to kind of show it off. And also we're getting black cables for everything. A black USB cord to connect to the black GoPro, and then I'll have white everything else. And I think it'll look very, very pretty. Hopefully, I have a nice 1 kilogram. Might not even be maybe like a 900 gram roll of the white. So I'm a probably print most of that for all of this. Because I mean, these sections here are going to be 14 millimeters long, or not 14 centimeters long, or 170, yeah. 14 on the inside, 170 on the outside, which is about the max my printer can do. It can do up to 18 by 18 centimeter. So I'm just gonna do 17 because there's that little extra filament that goes around them that's like, it's outside of the printing surface. It's like, well, I want it. You said I could print 18. Why can I not print 18? Yeah, we'll have that. So those pieces, those can be quite big. So I'm gonna be really sad if any of this doesn't work. And so I'm gonna try do everything I can to make sure it works once I print it, because I do not want to have to reprint a whole big section like this. Which is also why I put the holes through. So they look cool, and they'll take a bit of filament space. You don't need quite as much material for everything. And with that, hopefully, that'll be good to go. But we'll spend some time stress testing everything to make sure it is good to go. Which, really just going to stress test these two front pieces. The rest of these are fairly stubby. They're not going to have a whole lot of weight on them. It's just this piece and this piece are going to have all the weight on the front. Where these ones are. Not too much, and they're all fairly thick pieces, so they should be fine. Yeah. Leave it at that. And I guess thank you for watching. See you on Thursday. Hopefully my voice is a little bit better for then. Wasn't too bad today, but it would be nice to not be sick.